Good morning all. I am Dr. Raj Mohammed, working as Associate Professor in the Department of CSE, KIT Kalangar Karnataka Institute of Technology, Coimbatore. So I am here to share a few things about lexical analysis, which anybody can go through before getting into what is actually a lexical analysis. So this is one important aspect of compiler design. Before we step into the compiler design subject, we must know what is lexical analysis. So today's objective is to understand what is the exact role of analyzer with a real life analogy. That means a real life example. So let's get into the topic then. So what is a lexical analysis? So it is the very first phase of the compiler, and that it converts the source program into tokens. Here the source program, in the sense it can be a C program or a C++ or a say a script or whatever it is, so which is going to be compiled. Then what it does is that it removes the white spaces and comments. So for example, when we write a C code or a C++ code, we will be following the syntax of the respective programming language. So here the keywords are to be recognized first. How it is going to be recognized? By sieving them, or by tokenizing them. So the process of tokenizing them is happening within the source code, and then there may be extra white space or comments or special characters or blank spaces or intentionally left out spaces or braces, like that stuff will be there in part of the program that need to be identified. And for example, sometimes we also introduce functions with open and close brackets or braces, like that will also be recognized. And then after recognizing all these things, now these tokens will be supplied to the syntax analyzer, so that the code lies within the rules, that means syntax of the specific programming language. Then in lexical analysis, the following things will happen. That means we start with the source program. Source program is going to be analyzed through the lexical analyzer, and the lexical analyzer's output is going to be the tokens. Tokens in the sense keywords, which are legally recognized. That means it actually acts as an interface between the source code and the parser. So lexical analysis does operate as an interface between the source code and the parser. Parser is the one which is going to construct the derivation tree for us, so that it can be evaluated and then simplified, then produce expected results. So what the parser is going to do is that simplify the syntax analysis by tokenization. Let's get into the tokenization part. So here there are basic terminologies like the word which I have used often, that is token. What is token in terms of a program is that there is a category called lexical unit. Here two examples are given. ID means we know that it is identifier or a keyword. For example, ID, I declare a variable here, for example count. So here count is going to be an identifier, and say for example keywords are the reserved keywords used by the corresponding program. If you take the case of C or C++, you will be using hash include or void, main, printf, scanf. These are the words which are called as keywords. The identifiers are the variables name used by the programmer. And then comes the lexemes, or the actual sequence of characters. For example, if I am writing count, COUNT, that it has a specific name given by myself. Whereas in terms of reserved keywords, for example void, VOID, it's a sequence. And then after following void, there has to be main. And then main may be having what? Argument count or argument vector, depending upon the type of compiler or the mode of program what we are going to use. Then comes the pattern. So the pattern is nothing but a rule describing how a token need to be written. Here a classic example is int count is equal to 10, which is a perfect example. Let's get into another aspect of tokens. See here, keywords like int, if, while, select, case, continue, void, main, return, import, a system dot system or out or println. Likewise, in different programming languages, different keywords are there, and then identifiers that falls into the category which is described by the programmer based on the type of the problem or depending upon the situation. And then you have operators, all sorts of operators, logical, say special characters and all, so many stuffs are there. Then followed by literals or nothing but elements or values, like 10 or the 3.14 pi value, likewise now we give, and followed by separators, like colon or semicolon or comma or open close brackets and all. And we are not limited to these. Here comes a real life example. Say airport security is there, where the passengers are nothing but our source program. Consider passengers as source program, and there will be a security check happening then, and that has to be analyzed as a lexical analyzer. So passengers will be going one by one. There will be a security check, and he will be verifying the validity of each passenger one by one by verifying the valid documents. So once the document or the passenger is valid, and the passenger would be allowed inside, that means tokens will be allowed inside. Suppose if any passenger is not having a valid token, that means for example errors or ignored, something like ignored characters and all, and that will be invalidated, or that means removed. So passengers or the source code which are legally within the rules or frameworks of the specific programming language only will be allowed, whereas remaining will be rejected. So we have a clear example of how source program converted into tokens using lexical analyzers, and these tokens will be given into the syntax analyzer in the second phase of compilation. So the main function of lexical analyzer is token generation. Token means legal keywords, legal identifiers to be recognized, and then removal of unwanted components like white spaces, comments which are not part or not required, as when we go into compilation, space and time stuff, all these things will come into some important aspect. And then we have a simple table where all the identifiers, variables which were declared by the user would be coming into picture. The simple table is the one that will be referred again and again in tandem by the compiler for verification whether the variable is legally declared or whether the variable is having value, or associated with a specific code segment. And then it goes into lexical error reduction. Suppose if a statement was recognized but not getting converted into the corresponding token, and then there has to be a chance of lexical error, and that need to be detected and then fixed. So here let's see a classic example of lexical error. For example, I am using invalid characters like at or hash in the wrong context. For example, at is not used in C program, whereas at is used in Python and all, like that. Whereas the hash is widely used in standard programming like C or C++ and all, not used in programming languages like Java or other stuff. So characters which are legally accepted in the respective compiler need to be pushed in, whereas remaining things should be invalidated. And then misspelled keywords, for example int count is there, but instead of typing as count I say as a count, I leave the last character by for maybe a typing mistake and all. So misspelled keywords, so whichever keyword was typed as first, and that would be recognized throughout the code, throughout the program. And then unterminated strings, like you wanted to terminate a string by comma or semicolon or whatever it is, and that need to be done here. If it is not done, that will trigger an error. Here you can see an example, int to count, which is legally violating the conditions or the syntax of the programming language, because any variable or identifier cannot start with a numeric value. Only alphanumeric characters are allowed. So it is very, very evident or very clear that this specific code is having error. So such errors need to be identified. And then what the lexical analyzer is going to do is it will go to the symbol table. So it identifies the identifier which is correspondingly stored in the symbol table, and if it matches with that, then it will return as legal identifier. And then attributes. For example, int count is equal to 10. The type of the data is integer, and that leads to what? Attributes, like what's the corresponding name I have given. Name is count. What is the type? It is integer. So what is the scope? If I had written the code, declared the variable inside a function, it will be within that function segment. If it is declared globally, and it will be having global scope. So local and global scope of the variable need to be identified. And then later during the compiler phases, this lexical analyzer may help me in simplifying certain problems while trying to convert the lexical analyzer inputs into inputs to be processed by the syntax analyzer. So let's get into the summary part. So the lexical analyzer is the first phase of the compilation. What it does is that it breaks the source code into tokens and then simplifies them to be parsed. That means simplifies for parsing purpose, and then it acts as a filter like a real life verification system in which we have used airport security system. So thank you all.